There is a tooth. It rests in your hand with unexpected weight. Not the weight of stone exactly, though it has become stone over time. The weight of density, of compression, of something that was once alive and is now mineral. The surface is smooth in places, polished by sand and wind, and the patient movement of water through rock layers that no longer exist. In other places, the enamel is rough, textured like the bark of a tree that grew in darkness. The edges are serrated, not like a kitchen knife, like a saw designed by something that understood flesh at a mechanical level. Each serration is a small triangle, perfectly spaced, engineered by millions of years of trial and error. The tooth is 6 inches long. That measurement means nothing until you place it against your palm. Then it becomes real. Your hand disappears behind it. This tooth, this single tooth, is longer than your fingers. It curves slightly like a scythe. The root is thick, porous, darker than the crown. It feels ancient in a way that transcends the intellectual knowledge of age. You know factually that this object is millions of years old, but holding it creates a different kind of knowing, a physical knowing. This was inside the mouth of an animal, not metaphorically, not theoretically, literally embedded in living tissue, surrounded by muscle and blood and the electrical signals that controlled movement. This tooth cut through skin, through blubber, through bone. It was a tool, a weapon, a solution to the problem of hunger. The animal that used this tool is called Megalodon. The name means big tooth, which is simultaneously accurate and completely insufficient. A bus is big. A building is big. This tooth suggests something beyond bigness. It suggests wrongness. An animal that should not have been possible. But it was possible. It existed. It hunted. It ate. It reproduced. It died. And now, 3 million years after the last of its kind vanished from the oceans, you hold a piece of its body in your hand. The desert around you is silent. Flat red earth stretching in every direction. Mesas in the distance, layered like pages in a book written by geology. This tooth was found in a dry riverbed, half buried in sediment that was once the floor of a warm, shallow sea. The river carved through rock. The rock released its secrets. And now the tooth sits in sunlight for the first time in epochs. There is no ocean here now. No water at all, except what falls occasionally from clouds. But the rock remembers. The fossils remember. Embedded in the stone are the compressed remains of ancient coral, the spiraled shells of ammonites, the vertebrae of fish that have no living relatives. This place was once underwater, not thousands of years ago. Millions. A time so distant that the continents were shaped differently. The stars were in different positions. The climate was warmer. The ice caps had not yet formed. And in that ancient ocean, Megalodon ruled. Not through dominance in the way we understand it. Not through territory or hierarchy. Through size. Through hunger. Through the simple biological fact of being the largest predatory shark that ever lived. To understand this animal, we must do something unnatural. We must leave the human world behind. Not physically. We cannot travel backward through time. But mentally, imaginatively, we must descend into deep time the way a diver descends into deep water. Slowly, with preparation, with the understanding that pressure increases the farther down you go. And at a certain depth, everything you thought you knew becomes irrelevant. The rules change. The logic shifts. What seems impossible at the surface becomes ordinary in the deep. Welcome to Info Jungle. If you enjoy calm, thoughtful documentaries about the natural world, consider subscribing. These videos are created to help you relax while learning at a gentle pace. Science works with fragments. A jaw here, a vertebra there, scattered teeth across continents and ocean floors. From these pieces, we build ghosts. Megalodon left no complete skeleton. Sharks are made of cartilage, not bone. Cartilage decays. It dissolves in seawater. It leaves almost nothing behind except the hardest parts. The teeth, the vertebrae. Occasionally, a fossilized impression in stone where a body once lay. So we reconstruct. We compare. We extrapolate. The closest living relative to Megalodon is the great white shark. Not a direct descendant, but a cousin separated by millions of years of evolution. The great white gives us a template, a starting point. We take its proportions and scale them upward. We take its behavior and imagine it amplified. We take its anatomy and stretch it to impossible dimensions. A great white shark grows to about 20 feet in length. Megalodon grew to 60, 3 times longer. But length is deceptive. Volume increases exponentially. A 60-foot Megalodon was not 3 times heavier than a great white. It was 30 times heavier. 50 tons. The weight of 10 elephants. The weight of a loaded semi-truck. All of it muscle and cartilage and predatory efficiency. Let us build this animal slowly. Start with the head. The skull alone would be taller than a grown human. The jaws could open wide enough to swallow a horse. The mouth was not just a mouth. It was a cave lined with teeth. 5 rows visible at any given time. Behind those, another dozen rows in various stages of development. A tooth factory. A biological conveyor belt that produced replacement teeth continuously throughout the shark's life. Lose a tooth while feeding. A new one rotates forward within a week. No downtime. No vulnerability. Just constant grinding replacement. Each tooth was a precision instrument. Triangular. Serrated. Designed to shear through flesh and bone with minimal resistance. The bite force of Megalodon has been estimated at 40,000 pounds per square inch. To put that in perspective, a great white bites with about 4,000 pounds of force. A saltwater crocodile, one of the most powerful biters alive today, manages 3,700. Megalodon exceeded them by an order of magnitude. It could bite through the steel hull of a modern car. It could crush bone like breadsticks. Its jaw was not just strong. It was apocalyptic. Behind the head, the body. Streamlined. Torpedo-shaped. Hydrodynamic in the way that only millions of years of refinement can achieve. The dorsal fin rose from the back like a sail. Taller than a human. Cutting through the surface of the water with the authority of a blade. The pectoral fins, wide and muscular, controlled pitch and roll. They allowed the shark to turn, to dive, to rise with precision despite its enormous mass. The tail, the caudal fin, was pure propulsion. A crescent-shaped engine that could accelerate 50 tons of shark to speeds approaching 30 miles per hour. Not fast by the standards of smaller fish. but devastating when combined with size. Momentum equals mass times velocity. At 60 feet and 50 tons, even moderate speed became unstoppable force. The skin was covered in dermal denticles, tiny, tooth-like scales that reduced drag and provided armor. Running your hand along a megalodon's flank would feel like running it along sandpaper. Rough, abrasive, designed to move in one direction only, forward. The eyes were small relative to body size, positioned on either side of the head. Black, emotionless, not because Megalodon was cruel, but because sharks do not experience emotion the way mammals do. They are older, simpler, more efficient. The eye of a shark is a camera, a sensor. It gathers light and transmits data. There is no malice in it, no joy, only information. Beneath the skin, a network of sensory organs. The lateral line, running the length of the body, detecting vibrations in water. The ampullae of Lorenzini, clustered around the snout, sensing electrical fields generated by living muscle. A megalodon could detect the heartbeat of a whale from miles away. It could feel the panicked thrashing of an injured seal through murky water in total darkness. It did not hunt with eyes alone. It hunted with its entire body. A living sensor array wrapped in muscle and teeth. This is what we build from fragments. This is the ghost we summon from stone. A shark longer than a city bus, heavier than 10 cars, equipped with jaws that could bite through bone and sensors that could detect fear itself. And this animal, this titan, was not a myth. It was real. It swam in oceans that covered the same planet you stand on now. It ate. It bled. It reproduced. It died. All of this happened, not in a story, in history. Stand on a beach, any beach. Watch the waves roll in. The water is blue or green or gray depending on the light and the sediment and the depth. It moves with rhythm. Predictable. Knowable. This is the ocean you understand. The ocean of cruise ships and cargo vessels, of fishing trawlers and research submarines, of surfboards and scuba gear. A space that has been measured, mapped, and domesticated by human effort. We know this ocean. We have named its currents. We have charted its depths. We have cataloged its species with scientific precision. The largest predator in this ocean is the orca, killer whale, apex predator of the modern seas, 25 feet long, 6 tons, intelligent, social, capable of coordinated hunting strategies that border on tactical warfare. Orcas hunt seals, fish, even other whales. They are formidable, magnificent, the undisputed rulers of their domain. And yet, an orca is small compared to Megalodon. A Megalodon could swallow an orca whole if it chose to. Not that it would. Orcas did not exist during Megalodon's time, at least not in their current form. But the comparison is useful. It gives scale. The great white shark, the animal that haunts human nightmares, grows to about 20 feet. Impressive. Dangerous. But 1/3 the length of Megalodon. 1/30th the weight. A great white next to a Megalodon would look like a child next to a truck. The whale shark, the largest shark alive today, grows to 40 feet. But it is a filter feeder. Gentle. Slow-moving. It eats plankton, not prey. It has no teeth worth mentioning. It is large, but it is not a predator. There is no living shark that occupies the niche Megalodon once filled. No creature in the modern ocean combines size and predatory behavior in the way Megalodon did. The throne is empty, and it has been empty for 3 million years. We live in a diminished ocean, not diminished in beauty or complexity, but diminished in scale. The giants are gone. The true apex predators, the animals that ruled through sheer biological excess, have vanished. What remains are the survivors, the adaptable, the efficient, the creatures that could endure change. Megalodon could not. But to understand why, we must first understand what Megalodon was. Not the reconstructed skeleton, not the fossil tooth, the living animal, the creature that swam and hunted and existed in an ocean we can barely imagine. An ocean warmer than today's, fuller, richer, an ocean where life exploded in every direction, filling every niche with strange and wonderful forms. That ocean is gone. It left no photographs, no video footage, only traces, impressions in stone, chemical signatures in sediment, the scattered bones of animals that no human eye has ever seen alive. But we can go there, not with a ship or a submarine, with thought, with careful extrapolation, with the patient assembly of clues. We can descend into the past the way a diver descends into the ocean, layer by layer, depth by depth, until the surface world disappears and we find ourselves in a realm governed by different rules. 3 million years ago, the Pliocene epoch giving way to the Pleistocene, the climate cooling, the ice caps forming, the ocean beginning its long, slow transformation into the water you see today. And in that ocean, in the final moments before the cold arrived in full, Megalodon hunted. It ruled. It dominated. It was apex. But apex does not mean invincible. It does not mean eternal. It means only this, at the top of the food chain. For now, until the chain itself breaks. Teeth are time capsules. Not metaphorically. Literally. A shark produces thousands of teeth in its lifetime. Each tooth once lost sinks. It falls through the water column, turning slowly, catching currents, drifting horizontally as it descends. Eventually, it reaches the ocean floor. Sediment accumulates. Sand, silt, the microscopic shells of dead plankton. Layer upon layer. The tooth is buried. Pressure increases. Minerals seep into the porous structure of the enamel. Over millennia, the organic material is replaced atom by atom with stone. The tooth becomes a fossil, not a copy, a transformation, the same object chemically rewritten. And because teeth are hard, because enamel is dense and resistant to decay, they endure. Long after the flesh has rotted, long after the cartilage has dissolved, long after every soft part of the shark has returned to the ocean. The teeth remain. Megalodon teeth have been found on every continent. In deserts that were once seabeds, in riverbeds carved through ancient stone, on beaches where tides expose layers of compressed time, in the deep ocean, dredged up by accident during cable-laying operations. The distribution is global. This was not a regional predator, not a shark confined to one ecosystem or one temperature range. Megalodon swam everywhere. Tropical reefs, temperate coastlines, the open ocean between continents. Anywhere large prey existed, Megalodon followed. The teeth tell us this. They also tell us size. The length of a Megalodon tooth correlates directly with the size of the animal. A 6-inch tooth suggests a shark around 50 feet long. The largest tooth ever found measures 7.4 inches. That shark was pushing 60 feet. Perhaps longer. Perhaps heavier than our estimates allow. We do not know the absolute upper limit of Megalodon size because we have not found every tooth. We have not excavated every fossil bed. There may be larger specimens still buried, still waiting, still holding secrets in their mineralized enamel. The teeth also show variation, differences in shape depending on position in the jaw. Front teeth are narrower, sharper, designed for gripping. Side teeth are broader, more triangular, built for cutting. Back teeth are smaller, functional but less critical. A Megalodon jaw was a tool kit. Each tooth specialized for a specific task. Together, they formed a cutting apparatus more efficient than any blade humans have designed. But teeth alone do not make a skeleton. We have found vertebrae, rare but real. Cartilaginous vertebrae reinforced with calcium. Thick discs stacked like coins. Each vertebra the size of a dinner plate. From these, we estimate body length. From body length, we estimate weight. From weight, we estimate metabolism. From metabolism, we estimate feeding requirements. The math is simple but staggering. A 50-ton predator needs food. Constantly. A Megalodon likely consumed several hundred pounds of meat per day. Perhaps more. To sustain that intake, it had to hunt successfully and frequently. It could not afford long periods without food. It could not afford injury that prevented hunting. Its entire existence was balanced on the edge of a caloric knife. Eat or starve. Hunt or die. This is what the fossil record tells us. Not the emotional life of the animal. Not its thoughts or fears. But the physics of its existence. The energetic reality of being enormous. And that reality had consequences. When the ocean changed, when the climate shifted, when prey became scarce or moved to colder waters, Megalodon faced a problem it could not solve. It could not shrink. It could not hibernate. It could not adapt quickly enough. Evolution works on timescales measured in millions of years. Climate change, at least in Megalodon's time, worked faster. Not as fast as the changes happening today, but fast enough. Fast enough that within a few 100,000 years, the warm, prey-rich oceans Megalodon depended on began to vanish. And Megalodon, for all its size and power, vanished with them. But that ending is still distant. Before extinction, there was life. Millions of years of successful predation. Of hunting and feeding and reproducing. Of dominating an ocean we can barely comprehend. To see that ocean, to swim in it even imaginatively, we must leave the surface behind. We must descend, not into physical depth, into temporal depth, into the Miocene, 15 million years ago, when the world was warmer, when the poles had no ice, when the ocean teemed with giants we have only begun to understand. That is where Megalodon lived. That is where it hunted. That is the world we must enter if we are to know this animal as it truly was. Not a fossil, not a tooth, but a living, breathing hunting machine. A shadow in warm water. A presence too large to ignore. The largest predatory shark that ever existed. And we are about to meet it. 15 million years ago. The Earth is warmer by several degrees. Not catastrophically. Not lethally. Just warmer. The ice caps that define modern geography do not exist yet. Antarctica has ice, but it is thinner, less permanent. The Arctic Ocean is open water for much of the year. Sea levels are higher. Coastlines are drawn differently. Florida is half submerged. The Mediterranean is a series of connected basins, not yet the single sea it will become. The Isthmus of Panama has not yet formed. The Atlantic and Pacific Oceans mix freely where Central America will eventually rise. This changes currents. It changes temperature distribution. It changes where nutrients flow and where life concentrates. The ocean is not blue in the way you imagine it. It is greener, richer, more turbid with plankton blooms that stretch for hundreds of miles. The water is warm. Even at depth, even in places that receive no sunlight, the temperature is several degrees higher than today's deep ocean. This warmth fuels metabolism. Cold-blooded creatures, fish and sharks and reptiles, function more efficiently in warm water. Their muscles fire faster. Their digestion processes quicker. They grow larger. Everything in the Miocene Ocean is slightly wrong if you are accustomed to the modern sea. The shapes are familiar. Sharks, whales, dolphins, seals, but they are not the same species. They are ancestors or cousins or entirely separate branches of the evolutionary tree that led nowhere. Ghost lineages, dead ends, experiments that worked for millions of years and then stopped working. The whales are different. Some have teeth where modern baleen whales have filter plates. Some are smaller, more dolphin-like in proportion. Others are larger, bulkier, adapted to different prey. There are whales that hunt other whales. Raptorial cetaceans with conical teeth, designed to pierce blubber and hold struggling prey. Leviathan, a sperm whale relative with jaws that rival megalodons in sheer destructive capacity. It hunts baleen whales. It competes with Megalodon for the same food source. The ocean is not a peaceful place. It never has been. But in the Miocene, the competition is different. There are more apex predators, more giants vying for the same resources. The ocean can support them because it is so rich. Because the plankton blooms feed small fish. The small fish feed larger fish. The larger fish feed seals and dolphins. The seals and dolphins feed sharks and toothed whales. And the baleen whales, filtering tons of krill and plankton daily, grow enormous. They are the foundation of the megalodon's world. Mobile food sources weighing tens of tons. Slow enough to catch. Large enough to provide weeks of nutrition. Without whales, Megalodon could not exist. The two species are locked in an evolutionary arms race. Whales grow larger to avoid predation. Megalodon grows larger to hunt them. Speed increases. Defensive behaviors become more sophisticated. But size remains the ultimate advantage. For both, the water itself feels different. If you could dive into the Miocene Ocean, if you could hold your breath and descend through the warm currents, you would notice the density, the thickness. The water is full of particles, Organic matter, plankton, suspended sediment from rivers that no longer exist. Visibility is lower than in the modern ocean. Not murky exactly, but not crystal clear. You see perhaps 50 feet in good conditions. Beyond that, shapes, shadows, movement without detail. This is where Megalodon hunts. In water warm enough to support its massive metabolism, rich enough to sustain populations of prey, murky enough to allow ambush. You are descending now, not through water, through time. The surface world, the world of fossils and museums and scientific reconstruction, is fading above you. You are entering the realm where Megalodon is not a concept. It is a presence, a physical reality moving through the same space you occupy. Ahead in the green-tinted distance, something moves. Not large, not yet. A juvenile, 12 feet long, still growing, still learning. It swims near the surface, where the water is warmest and the light still penetrates. Its dorsal fin cuts the water with tentative authority. Not the confident blade of an adult, but practiced, purposeful. This young shark is hunting, and you are about to witness something that has not been seen in 3 million years. The juvenile Megalodon swims along a shallow reef. The reef is not coral, not in the modern sense. It is a mixture of hard structures built by organisms that have no living descendants. Algae forests sway in the gentle current. Small fish dart between the fronds, their scales catching the filtered sunlight. The young shark is hunting these fish, not because they provide significant nutrition. A 12-foot Megalodon needs more food than small reef fish can provide, but because hunting is a skill that must be practiced, refined, perfected before the shark grows large enough to take on dangerous prey. It moves slowly, almost lazy in its approach. The tail sweeps side to side with minimal effort. The pectoral fins adjust angle to maintain depth. It is conserving energy, not wasting movement. Already, even at this young age, the shark demonstrates the efficiency that defines its species. A school of fish scatters. The juvenile accelerates, not with the explosive speed of a smaller predator, but with building momentum. Mass in motion. Even at 12 feet, the shark weighs several hundred pounds. When it moves, the water moves with it. The fish scatter in all directions. Most escape. One does not. The jaws open. Not the cavernous maw of an adult, but impressive nonetheless. The teeth, smaller versions of the adult form, close on the fish. The bite is quick, efficient. The fish is swallowed whole. The shark continues swimming. One fish is not enough. Not nearly enough. A juvenile Megalodon of this size requires perhaps 50 pounds of food per day. More during growth spurts. The biological commitment to size begins early. Megalodon does not grow slowly and steadily. It grows aggressively, a foot or more per year during adolescence. This requires enormous caloric input. Protein, fat, minerals for bone and cartilage development. The young shark will spend most of its waking hours hunting or searching for food. There is no leisure in this existence. No rest beyond what is necessary for digestion. Only the constant, grinding need to eat. The reef provides some food, but not enough. As the shark grows, it will move to deeper water, to open ocean, to places where larger prey congregates. But that transition is dangerous. Larger prey means larger predators. Adult megalodons, raptorial whales, other sharks competing for the same food sources. Many juvenile megalodons do not survive to adulthood. They are eaten by competitors. They starve during periods of low prey availability. They suffer injuries that become infected. They are killed by parasites or disease. The ocean does not care about potential. It cares only about function. A 12-foot megalodon is functional enough to survive in shallow water. But moving to deeper water, to the hunting grounds of adults, requires more than function. It requires luck. This particular juvenile is lucky. It finds a nursery ground, a warm, shallow bay protected from the open ocean by a barrier of volcanic rock. Here, several other young megalodons swim. Not in a school exactly. Sharks are not social in the way fish or dolphins are. But they tolerate each other's presence. They are not yet large enough to compete directly. The bay is full of prey. Smaller sharks, rays, fish that spawn in the shallows, sea turtles, early pinnipeds, seal-like creatures that haul out on rocks to rest. The juvenile megalodon hunts a ray. The ray senses the approach and buries itself in sand. Only its eyes remain visible. The shark can sense it anyway. The ampullae of Lorenzini detect the electrical field generated by the ray's nervous system. Even buried, even motionless, the ray is visible to the shark's electromagnetic sense. The megalodon dives. Its snout strikes the sand where the ray is hidden. The ray erupts from the sediment in a cloud of silt. It flees. The shark follows. The chase is brief. The ray is fast, but not fast enough. The jaws close on the ray's wing. Teeth puncture flesh. The ray struggles, its barbed tail whipping. The barb strikes the shark's flank. It does not penetrate deeply. The dermal denticles and thick skin provide armor. The shark shakes its head, tearing the ray's wing. Blood clouds the water. The ray weakens. The shark feeds. This is the rhythm of young megalodon life. Hunt, feed, grow, repeat, day after day, month after month, year after year. The growth curve is steep. At 1 year, the shark is 10 feet long. At 2 years, 12 feet. At 5 years, 20 feet. At 10 years, 35 feet. At 20 years, approaching 50 feet. The curve plateaus eventually. Growth slows as the shark reaches physical maturity. But it never stops entirely. Megalodon, like many sharks, continues growing throughout its life. Slowly, incrementally. The oldest, largest individuals are the ones that have survived the longest. The ones that avoided starvation and injury and competition. The ones that were efficient enough, lucky enough, resilient enough to endure. Our juvenile will take decades to reach full size. If it survives. If the bay continues to provide food. If disease does not take it. If a larger predator does not find the nursery grounds. The ocean offers no guarantees. Only opportunities. And the opportunity to grow into the largest predatory shark that ever lived is an opportunity measured in constant, relentless hunger. 20 years have passed. The juvenile is gone. In its place swims an adult. 55 feet from snout to tail. 50 tons. The dorsal fin rises 7 feet above the water's surface when the shark cruises near the top. A sail, a landmark, visible for miles on calm days. This is not the same animal that hunted rays in shallow bays. This is something transformed, not just larger, different in kind. The physics of being this size change everything. The shark cannot accelerate quickly the way smaller predators can. It cannot turn sharply. It cannot hide. But it does not need to. Size confers advantages that speed cannot match. Momentum, power, the ability to survive injuries that would kill smaller animals. The jaws are monstrous. When fully opened, the gape measures nearly 6 feet across. A grown human could crouch inside and not touch the teeth. The teeth themselves are arranged in 5 functional rows. Behind them, 10 more rows in various stages of development. Each tooth is 5 to 7 inches long. Triangular, serrated like a steak knife. When the jaws close, the teeth do not simply bite. They saw. The serrations catch on flesh and drag through it as the shark shakes its head. The bite force, estimated through computer modeling and comparison with living sharks, reaches 40,000 pounds per square inch. To understand this number, imagine a car. A full-size sedan weighing 4,000 pounds. Now imagine 10 of those cars stacked on top of a single square inch. That is the pressure Megalodon's jaws could exert. It is enough to shatter bone, to crush vertebrae, to sever limbs, to kill prey not through blood loss, but through catastrophic structural damage. The teeth are continuously replaced. A megalodon produces roughly 20,000 teeth in its lifetime. Most are lost during feeding. They fall out, sink to the ocean floor, and are buried. This is why we find so many fossilized teeth. Not because Megalodon was common, but because each individual produced thousands. The body behind the jaws is equally imposing. The skin is gray-blue on top, fading to white on the belly. Countershading, a camouflage technique used by modern sharks. From above, the dark back blends with the deep water below. From below, the pale belly blends with the sunlit surface. Prey sees the shark only when it is too late. The skin itself is armored with dermal denticles. Each denticle is a tiny tooth embedded in the skin. They overlap like roof tiles. They reduce drag, allowing the shark to move more efficiently through water. They provide protection against parasites and opportunistic biters. They make the shark's hide rough as sandpaper. Running a hand along Megalodon's flank would tear skin. Draw blood. Not that anyone would be close enough to try. The eyes are small, black, positioned laterally for maximum field of view. Sharks do not have expressive eyes. There is no readable emotion in them. No anger or fear or hunger. Just focus, awareness, the mechanical attention of a predator evaluating its environment. But the eyes are only one sensory system. Perhaps not even the most important. The lateral line runs the length of the body. A canal filled with fluid and lined with sensitive hair cells. It detects pressure changes in the water, vibrations, movement. A struggling whale a mile away creates vibrations that travel through water like ripples across a pond. The lateral line picks them up, interprets them, gives the shark directional information without sight or sound. The ampullae of Lorenzini cluster around the snout. Hundreds of gel-filled pores connected to electroreceptor cells. They detect the weak electrical fields generated by muscle contractions. Every living thing produces these fields. A beating heart, a flexing muscle, a firing nerve. All of it generates electricity measurable in microvolts. The ampullae are sensitive enough to detect a single microvolt. A megalodon can sense the heartbeat of a whale from miles away. It can detect prey buried in sand or hiding in murky water. It can navigate using the Earth's magnetic field. This is not a simple predator. This is a biological sensor array wrapped in 50 tons of muscle and cartilage. It is a machine optimized by millions of years of evolution for one purpose: finding and killing large prey in open water. The tail provides propulsion, crescent-shaped, asymmetrical, with the upper lobe slightly larger than the lower. Each sweep of the tail pushes tons of water backward. Newton's third law ensures equal and opposite reaction. The shark moves forward, not quickly by the standards of smaller fish. Megalodon's cruising speed is perhaps 8 miles per hour. Leisurely, energy efficient, but it can accelerate when needed. Short bursts of 25 to 30 miles per hour are possible. For a 50-ton animal, this is extraordinary. The kinetic energy of 50 tons moving at 30 miles per hour is enough to capsize a boat, to break bones on impact, to drive teeth through blubber and muscle, and into the vital organs beneath. This is an adult megalodon, fully grown, apex predator, ruler of its domain. Nothing in the ocean is safe when this animal hunts. And it is always hunting, because 50 tons of shark requires constant fuel. And fuel in the Miocene Ocean wears the shape of whales. The whale is alone. This is its first mistake. It is a baleen whale, a primitive ancestor of modern rorquals. 40 feet long, 30 tons. It filters plankton from the water, straining tons of seawater through baleen plates to extract microscopic organisms. It is not a fast swimmer, not agile. Its body is optimized for efficiency, not escape. Under normal circumstances, this is acceptable. The ocean is large. Predators are relatively rare. The odds of encountering one are low. But today the odds have turned. The megalodon has been tracking this whale for 3 hours. Not actively chasing, just following, maintaining distance, observing. The shark swims several hundred yards behind and slightly below the whale. It matches the whale's pace exactly. 8 miles per hour. Effortless for both animals. The whale is unaware. It feeds as it swims, mouth open, filtering plankton. Its attention is on food, not danger. The megalodon is patient. Patience is a requirement for hunting large prey. A premature attack wastes energy and alerts the target. Better to wait, to watch, to identify the moment when conditions are optimal. That moment arrives when the whale dives. Not a deep dive. Baleen whales do not dive to great depths, but deep enough, 100 feet, into water where the light is dimmer, where visibility drops, where the megalodon's countershading makes it nearly invisible. The shark accelerates, still below the whale, still behind, closing distance. The tail beats faster. The body undulates. 50 tons of predator building speed, 20 miles per hour. 25. The water rushes past the shark's body. The dermal denticles channel flow. The jaws remain closed. The eyes focused. The whale senses something. A pressure change. A vibration. Its own lateral line, less developed than the shark's, picks up movement. The whale begins to turn. Too late. The Megalodon strikes from below and behind. The target is the tail. Specifically, the caudal peduncle, the narrow section where the tail connects to the body. This is the whale's propulsion system. Destroy it and the whale cannot flee. The jaws open, 6 feet across. The teeth, 5 inches of serrated enamel, close on the peduncle. The bite force is catastrophic. 40,000 pounds per square inch, concentrated on a section of the whale's body only a few feet thick. The teeth shear through blubber, through muscle, through blood vessels the diameter of a human arm. The whale's spine, thick cartilage and connective tissue, resists for a fraction of a second. Then it ruptures. The Megalodon shakes its head. Left, right. The serrated teeth saw through remaining tissue. The tail is not severed completely, but the damage is devastating. The whale cannot move its tail flukes. The muscles are destroyed. The nerves are cut. Blood pours into the water. Gallons per second. The whale tries to swim. It uses its pectoral fins, flapping desperately. But pectoral fins are not designed for propulsion. They are for steering, for balance. The whale moves forward a few feet, then stops. It begins to sink. The Megalodon releases its grip. It does not need to maintain the bite. The whale is crippled, bleeding, doomed. The shark circles, slowly, deliberately. It is not in a hurry. The whale is not going anywhere. The water around the whale turns red. Not bright red, dark red, rust-colored. The blood diffuses through the water, spreading in all directions. It attracts attention. Other sharks arrive. Smaller species, 10 feet long, 15. They are opportunistic scavengers. They dart in, bite pieces from the whale's tail and retreat. The Megalodon ignores them. There is enough food for everyone, and the smaller sharks are no threat. The whale is still alive. It floats just beneath the surface, breathing heavily. Each exhalation sends a spout of mist into the air. The breaths are labored, irregular. The whale is in shock. Its body is shutting down. Blood pressure dropping. Oxygen depleting. It will be dead within the hour. The Megalodon waits. Hunting is not about killing quickly. It is about efficiency. Minimizing risk. A thrashing, desperate whale can still injure a predator. A tail strike from 30 tons of whale can break bones, rupture organs. Even a Megalodon can be killed by its prey if it is careless. So the shark waits. It circles. It watches. The whale's breathing slows. The intervals between breaths grow longer. Finally, the whale stops breathing altogether. It sinks a few feet below the surface. Still buoyant but barely. Dead. Now the Megalodon feeds. It approaches the carcass from the side. The jaws open. The bite targets the whale's midsection, where the blubber is thickest. The teeth sink into flesh. The shark pulls backward, tearing a section of blubber and muscle free. The chunk weighs several hundred pounds. The megalodon tilts its head back. The meat slides down the throat. Swallowed whole. No chewing. Sharks do not chew. They bite, tear, and swallow. The digestion happens later, in a stomach capable of processing hundreds of pounds of meat at once. The shark takes another bite. And another. Each bite removes more of the carcass. Blood clouds the water completely now. Visibility is near zero. But the megalodon does not need to see. It uses its ampullae to locate the whale, its lateral line to sense position and orientation. It feeds by feel and electroreception. The smaller sharks grow bolder. They tear at the edges of the carcass. They consume scraps that drift away from the main body. One shark, a 12-foot specimen, bites too close to the megalodon. The megalodon turns, opens its jaws, bites the smaller shark in half. Not out of anger, out of reflex, out of the simple territorial instinct that defines apex predators. This is my food. Stay away. The other sharks retreat. They wait at a distance. The megalodon feeds for hours. It consumes perhaps a third of the whale's body mass. 1,000 pounds of meat. Enough to sustain it for a week. Maybe longer if it conserves energy. Eventually, the shark stops feeding. Not because the carcass is gone. Half of it remains. But because the shark is full. Its stomach is distended. Digestion will take days. The megalodon swims away. Slowly, lethargically, a predator temporarily satisfied. Behind it, the carcass continues to sink. The smaller sharks descend with it, feeding as it falls. By the time the whale's remains reach the ocean floor, little will be left. Bones, scraps of tissue, a few fragments of baleen. The ocean wastes nothing. Every death feeds something else. Every ending is a beginning. The megalodon swims toward open water, toward the blue void between continents. It will hunt again when hunger returns. And hunger always returns. The ocean has no borders, no fences, no signs marking where one territory ends and another begins. For most creatures, this does not matter. Territory is defined by behavior, not geography. A reef fish defends a few square meters of coral. A seal returns to the same haul-out year after year. But megalodon is not most creatures. At 50 feet and 50 tons, the concept of a small territory is meaningless. A megalodon's territory is measured in thousands of square miles, perhaps tens of thousands. The shark does not defend this space in the traditional sense. It does not patrol borders. It does not chase away intruders. It simply moves through it, following currents, following prey, following the thermal gradients that define the warm water it requires. Megalodon is a solitary animal. Outside of brief mating encounters, it spends its entire life alone. It does not hunt in packs. It does not coordinate with others of its kind. It does not communicate beyond the basic chemical signals all sharks produce. Solitude is not loneliness. Sharks do not experience loneliness. They do not have the neurological architecture for complex social emotions. Solitude is simply the default state, the most efficient way to exist when you are large enough to hunt alone. The shark follows the whales. This is the pattern that defines megalodon's life. Whales migrate seasonally. They move from cold, nutrient-rich feeding grounds to warm, shallow breeding grounds. From pole to equator and back again. Their migrations span entire ocean basins. Thousands of miles traveled over months. Megalodon follows. Not every whale. Not every migration. But enough. The shark moves between feeding aggregations. When whales gather in one region, Megalodon appears. When they disperse, the shark moves on. It is a nomadic existence. A life lived in transit. The open ocean is vast, empty in a way that terrestrial environments never are. On land, there is always something. Trees, rocks, hills, features that break up the landscape. In the open ocean, there is only water. Blue above, dark blue below. The same in every direction. No landmarks, no reference points, just the endless, rolling motion of currents and swells. A human would go mad in this environment. The sensory deprivation, the lack of stimulation, the sheer scale of emptiness. But Megalodon is not human. It navigates by senses humans do not possess. It detects the Earth's magnetic field. Subtle variations in field strength provide directional information. North and south. Latitude. The shark can navigate across an ocean using only magnetic cues. It also follows scent. Blood in the water. Chemical signatures from whale aggregations. Pheromones from other sharks. All of these dissolve into the water and spread. Currents carry them hundreds of miles. A megalodon can detect prey from distances that seem impossible. The shark is not wandering randomly. It is following invisible trails through the water, chemical highways that lead to food. Sometimes the trails converge. Two megalodons following the same scent, approaching the same prey aggregation. When this happens, there is no battle, no territorial display. Sharks are not territorial in the way mammals are. They tolerate each other. They feed side by side if food is abundant. If food is scarce, the larger shark feeds first. The smaller shark waits. This is not deference. It is practicality. Challenging a larger megalodon is suicidal. The size difference alone determines hierarchy. Occasionally, two sharks of similar size meet. When this happens, they may interact, circling each other, assessing, looking for signs of weakness or injury. If both are healthy, they usually part ways. There is no benefit to fighting. Injuries sustained in combat can be fatal. Infected wounds, broken jaws, damaged fins. A megalodon cannot afford to be injured. It cannot afford to hunt inefficiently. So confrontations are rare, brief, resolved through display rather than violence. Mating is different. Mating requires contact. Male sharks possess claspers, modified pelvic fins used to transfer sperm. The process is violent by human standards. The male bites the female to maintain position. His teeth leave scars, deep gouges in her thick hide. The female tolerates this. She has no choice. Shark reproduction is not gentle. It is functional. The mating encounter lasts minutes. Then the sharks separate. They do not bond. They do not raise offspring together. The male departs. The female carries the fertilized eggs inside her body. Megalodon is ovoviviparous. The eggs hatch internally. The embryos develop inside the mother, feeding on unfertilized eggs. It is a form of intrauterine cannibalism. The strongest embryos consume the weakest. By the time the female gives birth, only a few pups survive. Perhaps 4 or 5. Each is already 6 to 10 feet long. Born fully functional, capable of hunting immediately. The mother provides no parental care. She gives birth in shallow, warm water, a nursery ground protected from larger predators. Then she leaves. The pups are on their own. Most will not survive to adulthood. They will be eaten by other predators. They will starve. They will succumb to disease. But a few will survive. And those few will grow into the apex predators of their generation. This is the cycle. Migration, hunting, mating, birth, repeated across millions of years, across thousands of generations. The pattern is stable, sustainable. Megalodon has existed in this form for roughly 20 million years. It has survived climate fluctuations, volcanic eruptions, asteroid impacts. It has outlasted countless other species. It has dominated the ocean for longer than humans have existed. But dominance is not permanence. And the ocean, patient and indifferent, is about to change. The ocean is not a collection of individuals. It is a web, a network of relationships so complex that removing one strand can destabilize the entire structure. At the foundation, microscopic, phytoplankton, single-celled organisms that photosynthesize like plants. They drift in the upper layers of the ocean where sunlight penetrates. They bloom in numbers that defy comprehension. Billions per cubic meter of water. They are invisible individually. But collectively, they turn the water green. They produce half the oxygen in Earth's atmosphere. They are the base of everything. Zooplankton feed on phytoplankton. Tiny crustaceans, larval fish, jellyfish. They consume the photosynthesizers and convert plant matter into animal protein. Small fish feed on zooplankton. Herring, anchovies, species that school in groups numbering millions. They filter the water, straining plankton through their gills. Larger fish feed on the small fish. Tuna, mackerel, primitive billfish with spears longer than swords. They are fast, agile, built for the open ocean. Seals feed on fish. Early pinnipeds, not yet the specialized forms that will evolve later. They are clumsy on land but graceful in water. They dive deep, holding their breath for minutes. They surface to breathe, vulnerable and exposed. Dolphins feed on fish and squid. Toothed cetacean, smaller than whales, faster than seals. They travel in pods. They communicate with clicks and whistles. They coordinate their hunting, surrounding schools of fish, driving them to the surface, taking turns feeding while others maintain the circle. Baleen whales feed on everything smaller than themselves. They filter plankton and small fish through baleen plates. They consume tons of food daily. They are the largest animals in the ocean. Slow-moving, vulnerable, essential to the ecosystem because their waste fertilizes the phytoplankton, completing the cycle. And Megalodon feeds on the whales. It sits at the apex, the top of the pyramid. But the pyramid is not stable. It requires constant energy input from the sun. constant production from the phytoplankton, constant flow of nutrients from deep water to surface. If any part fails, the entire structure collapses. Megalodon exists because the ocean is productive enough to support whales. And whales exist because the ocean is productive enough to support massive plankton blooms. Remove the plankton and the whales starve. Remove the whales and Megalodon starves. The connections are not obvious. They are separated by multiple steps. But they are absolute. Megalodon does not hunt plankton. It barely notices them. But without them, it cannot exist. This is the fragility hidden beneath size and power. The vulnerability of specialization. Megalodon is adapted to hunt large prey in warm water. It cannot switch to smaller prey. Its metabolism is too high. It cannot consume enough small fish to meet its energy needs. It cannot hunt in cold water. Its body does not retain heat the way warm-blooded predators do. Cold water slows its metabolism, makes it sluggish, reduces hunting efficiency below survival threshold. Megalodon is powerful, but it is not flexible. And in the Miocene Ocean, flexibility is beginning to matter. Because Megalodon is not the only apex predator. There are competitors, other giants that hunt the same prey. Leviathan, a sperm whale relative with teeth the size of megalodons, 40 to 60 feet long, 30 to 50 tons, a macropredator capable of killing baleen whales. It has one advantage Megalodon lacks. It is warm-blooded. Leviathan can hunt in colder water. It can dive deeper, pursuing prey into zones where Megalodon cannot follow. It can migrate farther, accessing feeding grounds closed to sharks. The two species compete directly. They hunt the same whales. They occupy the same ecological niche. When they encounter each other, the outcome is uncertain. Megalodon has the stronger bite. Leviathan has greater endurance and intelligence. Sometimes Megalodon wins. Sometimes Leviathan wins. More often, they avoid each other. The risk of injury is too high for both. But their coexistence creates pressure. Each must be more efficient, more opportunistic, more willing to take risks. There are other competitors. Larger sharks, not as large as Megalodon but significant. Great whites are beginning to evolve. Smaller, faster, more adaptable than Megalodon. They hunt seals and smaller whales. They compete with juvenile megalodons for prey. They are more efficient in cooler water. There are also raptorial fish, giant predatory relatives of modern tuna and swordfish. 10 feet long, vast, equipped with sharp teeth and powerful jaws. They do not threaten adult Megalodon, but they compete with juveniles. They eat the same fish, hunt in the same reefs. Every layer of the food web has competition. Every niche is contested. The ocean is not a peaceful place. It is a battlefield where the weapons are teeth and speed and efficiency. And the prize is survival. Megalodon dominates. But dominance requires constant effort, constant hunting, constant success. There is no margin for error, no safety net. A Megalodon that fails to hunt successfully for a few weeks will weaken. A weakened Megalodon cannot hunt efficiently. Inefficient hunting leads to starvation. Starvation leads to death. The ecosystem does not mourn. It simply reallocates the energy. Scavengers consume the carcass. Nutrients return to the water. Phytoplankton bloom. The cycle continues. Individual megalodons die, but the species persists. For now, because the ocean remains warm, because the whales remain abundant, because the conditions that allow 50-ton sharks to exist remain stable. But stability is temporary, and change, when it comes, will not announce itself. It will arrive slowly, incrementally, a fraction of a degree cooler each century, a slight shift in current patterns, a gradual migration of prey to different waters. Small changes, unnoticeable in a single lifetime, but accumulating, building, moving toward a threshold that once crossed cannot be uncrossed. We do not know how Megalodon made it. We can infer, extrapolate from living sharks, but we cannot know with certainty. The fossil record preserves bones and teeth. It does not preserve behavior, but behavior leaves clues. Scars on fossilized bones, tooth marks in specific patterns, geographic distribution of fossils suggesting seasonal movement. From these fragments, we build hypotheses. Megalodon likely mated in offshore waters, away from coastlines, away from shallow reefs, in the open ocean where large animals could maneuver without obstruction. The process was probably violent. Male sharks bite females during mating. It is how they maintain position, how they hold on while transferring sperm. For smaller sharks, these bites leave minor wounds. For Megalodon, the bites would be catastrophic on any other animal. But female megalodons had thick skin, extra layers of dermal armor around the gills and flanks, the areas most commonly bitten during mating. The bites left scars, deep gouges that healed over time. A mature female megalodon would be covered in these scars. A map of every mating encounter, every successful reproduction. Males competed for access to females. Larger males had advantages. They could displace smaller rivals. They could endure the physical demands of mating. Mating itself required strength, coordination, the ability to match speed and direction with another 50-ton animal in open water. It was brief, minutes, not hours. Then the sharks separated. The male returned to solitary hunting. The female carried fertilized eggs inside her body. Gestation lasted perhaps 12 to 18 months. During this time, the female continued hunting, continued migrating. Her body provided nutrients to the developing embryos, but the embryos also consumed each other. Inside the uterus, a miniature battle. The largest, strongest embryos ate the smaller, weaker ones, and unfertilized eggs provided additional nutrition. This is called oophagy, egg eating. It is common in large sharks. It ensures that only the most viable offspring survive to birth. By the time gestation ended, perhaps 4 to 6 pups remained. Each was already massive, 6 to 10 feet long, 100 pounds or more. Born alive, fully formed, capable of swimming and hunting immediately. The female gave birth in warm, shallow water, a protected bay, a lagoon, somewhere with abundant prey and few large predators. These nursery grounds were crucial. Without them, the pups would be vulnerable. In open water, they would be prey for adult megalodons, for Leviathan, for other large sharks. Even their own mother might eat them if she encountered them after birth. Sharks have no parental bonds, no recognition of offspring. A 6-foot shark is simply a potential meal. So the female gave birth and departed. She returned to deep water, to her solitary existence. The pups remained in the nursery. They hunted fish and rays. They grew rapidly, a foot per year during the first decade. Those that survived would eventually leave the nursery. They would venture into deeper water, into the realm of larger predators. Many would not survive this transition. Perhaps only 1 or 2 from each litter reached adulthood. But those that did would live for decades, possibly a century. Shark aging is difficult to determine. We count growth rings in vertebrae. Like tree rings, they represent annual growth cycles. The largest Megalodon vertebrae show growth rings, suggesting ages of 70 years or more. Possibly 100, possibly longer. We do not know the upper limit. An adult Megalodon that reached 50 feet might hunt successfully for 40 or 50 years. It would accumulate scars, broken teeth, healed wounds from failed hunts or encounters with prey that fought back. Older Megalodons were veterans. They had learned which prey was safest, which hunting techniques were most efficient. They had survived starvation periods, storms, injuries that would have killed younger, less experienced sharks. Their bodies showed the history. Notches in fins from old bites. Asymmetry in the jaw from broken cartilage that healed incorrectly. Missing teeth that never regenerated properly. But they were still formidable. Still apex. Experience compensated for declining physical condition. An old Megalodon knew where prey migrated, when whales would appear in specific waters. It knew which currents carried the richest scent trails. It had decades of accumulated knowledge, not conscious knowledge. Sharks do not think in the way mammals do, but learned behavior. Neural pathways reinforced by repetition. Instinct refined by experience. An old Megalodon was a more efficient hunter than a young one. Not faster, not stronger, but smarter in the limited way that sharks can be smart. And efficiency was everything, because the ocean was beginning to change. Slowly, imperceptibly within a single lifetime, but changing nonetheless. The currents were shifting. The temperature was dropping. The prey was adapting. And Megalodon, for all its power, for all its millions of years of evolutionary success, was not equipped to adapt quickly. Evolution works on timescales measured in millennia, in hundreds of thousands of years. The changes coming to the ocean would unfold faster than that. Not fast by human standards, but fast by evolutionary standards. And Megalodon, locked into its specialized niche, would have nowhere to go. There is a paradox in being apex. You have no predators. Nothing hunts you. Nothing sees you as food. But you are not invulnerable. You are not safe. Because the ocean does not care about your position in the hierarchy. It cares only about function. And anything that stops functioning dies. Megalodon feared injury. Not in the conscious sense. Sharks do not experience fear the way mammals do. But behaviorally, Megalodon avoided situations that might cause injury. It avoided healthy, aggressive prey. It targeted the weak, the young, the isolated, the injured. A whale traveling in a pod was dangerous. Multiple whales meant multiple tails, multiple opportunities for a defensive strike. A megalodon could kill one whale, but 5 whales working together could injure or kill the shark. So Megalodon hunted alone whenever possible. Stragglers, sick whales that fell behind the migration. Juveniles separated from their mothers. This was not cowardice. It was efficiency. Why risk injury when safer prey was available? But sometimes, safer prey was not available. During lean periods, Megalodon had to take risks. Attacking healthy adults, approaching pods, and sometimes the prey fought back. A whale's tail is a weapon. 30 tons of muscle accelerated through water. The flukes are wide, hard, reinforced with dense connective tissue. A tail strike could break a megalodon's jaw, shatter vertebrae, rupture internal organs. A shark with a broken jaw could not feed. Starvation would follow within weeks. A shark with damaged vertebrae could not swim properly. It would sink, suffocate, drown in the ocean that was its home. Megalodon also feared other megalodons. Cannibalism was common, not out of malice, out of opportunism. A large megalodon encountering a smaller one saw prey. Size determined safety. Juveniles were most vulnerable. Even in nursery grounds, larger siblings sometimes ate smaller ones. In open water, a 20-foot megalodon was prey to a 50-foot adult. This created pressure to grow quickly, to reach a size where other megalodons no longer posed a threat. But growth required food, and food was not always available. There were also diseases, parasites. We find evidence of infection in fossilized bones, lesions, abnormal growth, signs of chronic illness. Sharks are resistant to many diseases. Their immune systems are ancient and efficient, but they are not immune to everything. A bacterial infection in a wound could spread. A parasitic infestation could weaken the shark, reduce hunting efficiency, lead to starvation. The ocean also contained environmental hazards, volcanic eruptions underwater, sudden temperature changes, toxic algae blooms. Any of these could kill even an apex predator. A megalodon swimming through a dense algae bloom might ingest toxins. The toxins would accumulate in its liver, interfere with metabolism, cause organ failure. And there was no cure, no recovery, just a slow decline into dysfunction and death. But the greatest threat was subtler. It was not a predator, not a disease, not an environmental hazard. It was change itself. The slow, inexorable shift in conditions that had allowed Megalodon to thrive. The ocean was cooling. Not everywhere, not uniformly, but in specific regions. The poles especially. Ice was beginning to form. Glaciers building on Antarctica. The Arctic Ocean freezing for longer periods each year. This had consequences. Cold water is denser than warm water. It sinks. The sinking cold water drives deep ocean currents. These currents redistribute nutrients. They change where plankton blooms occur, where fish congregate, where whales feed. The entire food web was shifting, reorganizing around new thermal patterns. Whales adapted. They were warm-blooded. They could regulate their body temperature. Cold water was uncomfortable, but not lethal. Some whale species began spending more time in polar waters. The feeding was better there. The plankton blooms were denser. The risk was worth the discomfort. Megalodon could not follow. Cold water slowed its metabolism, made it sluggish, reduced hunting efficiency. A megalodon that spent too long in cold water would starve. Not because food was absent, but because it could not hunt effectively enough to catch it. This created a problem. Prey was migrating to waters Megalodon could not access. The warm, equatorial waters that Megalodon preferred had less food. Fewer whales, smaller populations, less reliable prey availability. Megalodon was being squeezed, confined to a shrinking range. And within that range, competition was intensifying. More megalodons competing for fewer whales. Juvenile survival rates dropped. Fewer pups lived to adulthood. Population growth slowed, then stopped, then reversed. This did not happen quickly. It took thousands of years, tens of thousands. No individual megalodon experienced the entire decline, but each generation faced slightly harder conditions than the last. Slightly less food, slightly more competition, slightly narrower temperature tolerance. The species was not dying. It was fading, thinning, becoming less common, less widespread, less dominant. The ocean was indifferent. It did not care that Megalodon had ruled for 20 million years. It did not care about size or power or evolutionary success. It cared only about function. And Megalodon's function was becoming obsolete. 3.5 million years ago. The Pliocene epoch. The world is cooling. Not rapidly, not catastrophically, but persistently. A fraction of a degree per millennium. Compounding, accumulating. The ice caps are expanding. Antarctica is covered in ice kilometers thick. The Arctic Ocean freezes solid each winter. Glaciers form in mountain ranges that previously had none. Sea levels drop as water is locked in ice. Coastlines retreat. Shallow seas drain. The geography of the ocean changes. The Isthmus of Panama is rising. Tectonic forces pushing land upward. Soon, within a few 100,000 years, it will close completely. The Atlantic and Pacific will be separated. Currents that have flowed freely between the oceans for millions of years will be blocked. This will change everything. Ocean circulation, heat distribution, nutrient flow. The entire system will reorganize. But that closure is still in the future. For now, the currents are simply changing, shifting. The warm water that once flowed freely is being diverted. Cold water from the poles is penetrating farther toward the equator. The boundary between warm and cold is moving. Slowly, but moving. Whales notice. Not consciously, but their migration patterns shift. They spend more time in polar waters where food is abundant. Less time in equatorial waters where food is becoming scarce. Their bodies adapt. Blubber thickens, providing better insulation, allowing them to tolerate colder temperatures. Their size increases. Larger bodies retain heat more efficiently. The whales of the Pliocene are evolving into the giants of the Pleistocene. Blue whales, fin whales, the largest animals that will ever exist. They are adapting to the cold, thriving in it. Megalodon cannot. Its metabolism is tied to water temperature. In warm water, it is efficient, powerful, dominant. In cool water, it slows. Its muscles respond less quickly. Its digestion takes longer. It requires more food to maintain body temperature. But food is becoming scarce in warm waters. The whales are leaving, following the productivity north and south, into waters too cold for Megalodon to hunt effectively. Megalodon's range shrinks. It is confined increasingly to a narrow band of warm water near the equator. Within this band, population density increases. More sharks competing for the same dwindling resources. Juvenile mortality rises. Fewer pups survive to adulthood. The population begins to decline. Not collapse. Not yet. But decline. The species is contracting, condensing into a smaller geographic area. This creates genetic problems. Populations that once interbred across thousands of miles are now isolated. Gene flow stops. Each population becomes inbred. Genetic diversity declines. This reduces adaptability, reduces the population's ability to respond to environmental stress. A genetically diverse population might produce individuals capable of tolerating slightly cooler water. A genetically uniform population cannot. It is locked into existing traits, existing tolerances, existing vulnerabilities. The climate continues cooling. The trend is clear. Not to us, looking back from millions of years in the future. But it would not be clear to Megalodon. Individual sharks do not live long enough to notice climate trends. A Megalodon born into a world with abundant prey would hunt that prey its entire life. If prey became scarce late in its life, it might starve. But it would not understand why. It would not recognize a pattern. It would simply experience the immediate reality of hunger, of failed hunts, of weakening, of death. The species has no memory beyond genetics. No way to pass information between generations except through DNA. And DNA adapts slowly. Too slowly for the changes happening now. There are other factors. Competition from warm-blooded predators. Great white sharks are evolving. Smaller than Megalodon, but more efficient in cooler water. They can hunt in regions Megalodon cannot. They are more flexible in prey selection. A great white can survive on seals, fish, smaller sharks. It does not require the massive caloric intake that Megalodon does. When whale populations decline, great whites switch prey. Megalodon cannot. Its jaws, its teeth, its entire hunting strategy is optimized for large prey. It cannot efficiently hunt smaller animals. It would expend more energy chasing them than it would gain from eating them. This is the trap of specialization. In stable conditions, specialists dominate. They are more efficient than generalists at their specific task. But when conditions change, specialists become vulnerable. They cannot adapt. They cannot pivot. They are locked into a niche. And if that niche disappears, they disappear with it. Megalodon's niche is disappearing. The warm, whale-rich oceans of the Miocene are transitioning, becoming the cooler, more stratified oceans of the Pleistocene. The transition takes hundreds of thousands of years. Plenty of time for evolution to adapt. In theory, but Megalodon reproduces slowly. A female might produce only 4 or 5 litters in her lifetime, each litter containing only a few pups, most of which die before reproducing. The generation time is measured in decades. The number of generations per million years is small. Too small for significant evolutionary change. Too small to develop cold water tolerance. Too small to shift to different prey. Too small to survive what is coming. The ocean does not care. It continues cooling, continues changing, continues becoming a place where Megalodon cannot exist. And Megalodon, for all its size and power and millions of years of success, has no response. It can only continue doing what it has always done. Hunting, feeding, reproducing, until those activities no longer sustain the population, until the deaths outnumber the births, until the species crosses a threshold from declining to doomed. That threshold is approaching. Not today, not this year, but soon. In evolutionary terms, very soon. Anatomy is destiny. For Megalodon, this is literally true. Every aspect of its body is optimized for a specific set of conditions. Warm water, large prey, open ocean. Change any of these variables, and the optimization becomes a liability. The shark size is the most obvious constraint. 50 feet, 50 tons. This requires enormous energy input. A megalodon's basal metabolic rate, the energy needed just to stay alive, is staggering. Thousands of calories per hour. Just to pump blood, to oxygenate tissues, to maintain cellular function. On top of that, add the energy cost of swimming, of hunting, of digesting massive meals. The total energy requirement is perhaps 20,000 calories per day. Maybe more. This can only be met by consuming large, energy-dense prey. Whales, with their thick blubber, their massive muscle mass. A single whale kill provides weeks of nutrition, but only if the kill is successful. And success requires specific conditions. Warm water keeps the shark's metabolism high, keeps its muscles responsive, keeps its hunting efficiency above the survival threshold. In cold water, everything slows. The chemical reactions that power muscle contraction occur more slowly. The shark moves more sluggishly. Reaction time increases. A whale that would be easy prey in warm water becomes difficult in cold. The shark might still make a kill, but it would expend more energy doing so, and it might not recover that energy from the meal. This is the critical threshold. When energy expended exceeds energy gained, survival becomes impossible. Not immediately. The shark can burn fat reserves, can metabolize its own muscle tissue. But this is temporary. A starvation response, not a sustainable strategy. Megalodon's inability to regulate body temperature is another constraint. Unlike mammals, sharks are ectothermic. Their body temperature matches the surrounding water. Some modern sharks, like great whites, have partial endothermy. They can maintain their core temperature slightly above ambient through a heat exchange system in their blood vessels. This gives them an advantage in cool water. Megalodon may have had similar adaptations. We cannot know for certain. But even if it did, the effect would be limited. A few degrees of temperature elevation at most. Not enough to hunt effectively in truly cold water. Not enough to follow whales to polar feeding grounds. The teeth are another constraint. Massive, serrated, perfect for killing whales, useless for catching fish. A megalodon attempting to hunt fish would be like a human trying to catch flies with a sledgehammer. Technically possible, practically inefficient. The energy return would not justify the effort. The jaw structure is similarly specialized. Wide, powerful, designed to open enormously and bite with catastrophic force, but not designed for precision, not designed for fast, agile prey. A seal could outmaneuver a megalodon. A dolphin could evade it indefinitely. The shark's entire body is built for hunting large, slow prey. When that prey becomes scarce or inaccessible, the shark has no backup strategy, no alternative diet, no behavioral flexibility. It is a biological machine with one function. And machines do not adapt. They operate within their design parameters or they fail. Megalodon is beginning to fail. Not through any fault of its own. Not through weakness or inefficiency. But through the simple fact that the world it was designed for is disappearing. The reproductive strategy is another vulnerability. Slow maturation. Decades to reach breeding age. Small litter sizes. High juvenile mortality. This strategy works in stable environments. In unstable environments, it is fatal. A species that reproduces quickly can adapt to changing conditions. It produces many offspring. Most die, but a few survive with traits suited to the new conditions. Those survivors reproduce, pass on their advantageous traits. Within a few generations, the population adapts. Megalodon cannot do this. Its generation time is too long. Its litter size is too small. Its juvenile survival rate is too low. By the time a genetic adaptation appears and spreads through the population, the environment has changed again. The species is always behind, always reacting to conditions that no longer exist, always one step too slow. This is the paradox of the apex predator. In good times, it dominates. It has no predators, no competition that can challenge it directly. It sits at the top of the food web, secure and powerful. But that security is an illusion. The apex predator is the most vulnerable species in the ecosystem because it depends on everything below it. Remove the plankton and the fish disappear. Remove the fish and the seals disappear. Remove the seals and the smaller predators disappear. And eventually, the apex has nothing to eat. The pyramid collapses from the bottom up. And the apex, for all its strength, falls the farthest. Megalodon is falling now. Not quickly, not dramatically, but falling nonetheless. Its population is declining. Its range is shrinking. Its genetic diversity is eroding. The biological machine is running out of fuel. And there is no mechanic who can repair it. No external intervention that can save it. Only the cold, indifferent process of natural selection, which is currently selecting against 50-ton sharks that cannot adapt to a cooling ocean. 2.5 million years ago. The population is a fraction of what it once was. Megalodon still exists. It still hunts. Still dominates the waters where it swims. But those waters are shrinking. Isolated pockets of warm ocean. Disconnected from each other. Each pocket contains a small population, perhaps a few dozen individuals, perhaps fewer. They do not encounter each other often. The ocean is vast. The sharks are few. Mating becomes rare, random, dependent on chance encounters. Some females go years without finding a mate. They continue hunting, continue migrating, but they produce no offspring. The population does not replace itself. Deaths outnumber births. Slowly, year by year, generation by generation, the numbers decline. The hunting grounds are smaller now, confined to equatorial waters, the Caribbean, the waters around Indonesia, the coast of West Africa, anywhere the currents still bring warmth. But even here, the whales are fewer. They pass through these waters during migration, but they do not linger. They feed in polar waters. They breed in warm waters. But the breeding season is brief, a few months. Then they depart. Megalodon hunts during these brief windows, targeting pregnant females, targeting calves, taking whatever opportunities arise. But opportunities are infrequent. Starvation becomes common. Sharks weaken. Their hunting efficiency drops. They take riskier prey, attack healthier whales, approach pods instead of waiting for stragglers. Some succeed, make kills that sustain them for another month, another season. Others fail. They are injured by defensive tail strikes, or they simply expend more energy than they gain. They weaken further. Eventually, they cannot hunt at all. They drift, slowly sinking, waiting for death. The scavengers find them before they reach the bottom. Smaller sharks, fish, they consume the carcass, return the nutrients to the ocean. The cycle continues. But fewer megalodons enter the cycle. Fewer juvenile survive the nursery grounds. Food is scarce even for the young. The easy prey, the abundant reef fish, are less common, overfished by growing populations of smaller predators. The juvenile megalodons compete poorly. They are slower, less agile, less efficient. Many starve before reaching 10 feet. Those that survive find an ocean that does not want them, that has no space for 50-ton sharks, that offers no path to adulthood except through luck and relentless hunting. Some get lucky. They find prey. They grow. They reach breeding age. But there are no mates. The population is too dispersed, too fragmented. A mature female might swim thousands of miles without encountering another megalodon. She hunts alone, ages alone, dies alone. Her lineage ends with her. This is happening everywhere megalodon still exists. In every isolated pocket of warm water, in every remnant population. The species is not dying all at once. It is fragmenting, breaking into smaller and smaller groups, each group declining independently, each group facing the same insurmountable problems. Too few individuals, too little food, too little genetic diversity, no path forward. The ocean does not mourn. It has seen species come and go. It has witnessed extinctions beyond counting. Megalodon is just one more. Impressive, certainly. The largest predatory shark that ever lived. But not exempt from the rules. Not special. Not eternal, just another species reaching the end of its evolutionary road. The last generations swim in waters that are no longer theirs. They hunt prey that has moved beyond their reach. They reproduce too slowly to replace losses. They are ghosts, echoes of a time when the ocean was warmer and richer and more forgiving. That time is ending, and Megalodon is ending with it. Not with a battle, not with a final, dramatic confrontation, but with a slow fade, a gradual disappearance, a quiet exit from an ocean that has already moved on. Somewhere in the warm waters, off what will one day be called Panama. 3.6 million years ago, a megalodon swims. It is old, perhaps 90 years, perhaps more. Its body shows the accumulation of a lifetime. Scars crisscross its flanks, deep grooves from mating encounters decades past, bite marks from competitors, scrapes from failed hunts. Some teeth are missing. The jaw is asymmetrical, where cartilage healed incorrectly after an injury. Decades ago, the injury healed, but the function never fully returned. The bite is weaker on one side. This makes hunting harder, less efficient. The shark compensates. It has learned to approach prey from specific angles, to bite with the stronger side of the jaw. Experience compensating for declining physical capacity. But experience only goes so far. The shark is hungry. It has not fed in 3 weeks. The last kill was a juvenile whale. Small, barely enough to sustain a shark this size. The meat was consumed within days. Since then, nothing. The hunting grounds are empty. The whales have migrated north, following the cold currents to feeding grounds rich with krill. A few whales remain in these warm waters, but they are scattered, difficult to find. The shark swims slowly, conserving energy. Its movements are economical. No wasted effort, no unnecessary motion. Just the slow, rhythmic sweep of the tail. Forward momentum maintained at minimum cost. The water is warm, clear. Sunlight penetrates 50 feet down. The shark swims at 100 feet, in the zone where light fades to blue-green twilight. Below, the ocean darkens to black. The abyss. The shark does not descend into it. There is nothing there for a surface predator. No whales, no prey, only cold and pressure and darkness. The shark's senses search the water. The lateral line detects distant vibrations. Something moving, far away, possibly prey. The shark alters course, following the signal, swimming for an hour, 2 hours. The vibrations grow stronger. Closer. The shark's pace increases slightly. Not much, just enough to close the distance. Ahead, shapes materialize. Whales. A small pod. 3 adults and a calf. The calf is young, perhaps a year old, 20 feet long, 10 tons. Vulnerable. The shark evaluates. The pod is tight. The adults are alert. They have detected the shark's presence. They position themselves between the shark and the calf. A defensive formation. This is dangerous. Attacking a protected calf means running a gauntlet of adult tails, each capable of delivering a killing blow. But the shark is desperate. Hunger overrides caution. It approaches from below, using the darkness as cover. Rising slowly toward the pod, the whales sense the approach. They cluster tighter. The calf is surrounded. The shark continues rising. It is now 50 feet below the pod. 40 feet. 30. The adult whales begin to descend, meeting the threat. This is unexpected. Normally, whales flee. They are faster than Megalodon over distance. They can escape. But this pod is not fleeing. It is defending. The largest whale, a female, descends directly toward the shark. Her tail sweeps side to side, building speed. She is not attacking. She is warning. Come closer and face consequences. The shark slows, evaluates. The whale is 40 feet long, 35 tons, healthy, strong. A fight would be costly, possibly fatal. But the shark is starving. It has no choice. It accelerates, angling to pass beneath the adult and reach the calf. The whale reacts. Her tail swings, a massive arc of muscle and fluke. It misses the shark's head by inches. The pressure wave pushes the shark sideways, disrupts its trajectory. The shark corrects, continues toward the calf. The second adult whale descends. Its tail strikes. This time contact. The fluke catches the shark's dorsal fin. The impact is tremendous. 30 tons of whale accelerating through water. The dorsal fin bends. Cartilage compresses. The shark is driven sideways, tumbling, disoriented. Pain floods its nervous system. Not pain as humans experience it. Sharks have different neural architecture, but damage signals, warnings that the body has been injured. The shark rights itself. The dorsal fin is damaged, not severed but torn. Blood seeps from the wound. The shark can still swim, but balance is compromised. Turning is more difficult. The pod of whales ascends. They do not pursue. They simply retreat, putting distance between themselves and the threat. The shark does not follow. It cannot. The injury prevents efficient swimming, and the energy expenditure would exceed any potential gain. The shark has failed. It drifts. Blood trails behind it. The wound is not fatal. Not immediately. But it will not heal properly. Cartilage does not regenerate well. The fin will remain damaged permanently. And a shark that cannot swim efficiently cannot hunt, cannot feed, cannot survive. The shark continues drifting. Days pass. Hunger intensifies. The body begins metabolizing its own tissue. Fat reserves, then muscle. The shark weakens. Swimming becomes labored, painful. The wound in the fin has become infected. Bacteria entering through torn tissue. The infection spreads slowly. The shark's immune system fights, but it is weakened by starvation, by age, by the accumulated stress of a lifetime. The infection wins. A week after the failed hunt, the shark stops swimming. It drifts passively, breathing slowly. The gills still move. Water still flows through them. Oxygen still extracts, but barely, just enough to maintain minimal function. The shark is dying. Not quickly, not dramatically, just fading. Systems shutting down one by one. There is no pain now, no awareness of the process, just a gradual dimming of sensation, of perception, of existence. The shark begins to sink, slowly at first, its body still slightly buoyant. But as the gills stop moving, as the last oxygen leaves the tissues, buoyancy fails. The shark descends through the blue-green twilight, through the thermocline where warm water meets cold, into the dark. The body tumbles slowly, rotating. The damaged dorsal fin causes asymmetric drag. The shark spirals downward, like a falling leaf, turning end over end. The water grows colder. The pressure increases. At 500 feet, the sunlight is gone completely. Only darkness. The shark's body continues falling. 1,000 feet. 2,000. The pressure is immense. But the shark does not feel it. Cannot feel it. The body is dead. Just organic matter obeying gravity. At 3,000 feet, the descent slows. The ocean floor is approaching. Sediment rises in gentle slopes. Ancient deposits of dead plankton, compressed over millions of years into soft ooze. The shark's body impacts the sediment. Gently. After such a long fall, the final contact is almost tender. The body settles, creates a small depression, disturbs the ooze slightly. Then stillness. Complete. Absolute. The last megalodon has come to rest. Not the last in the world. There are others, scattered across isolated pockets of warm water. A few dozen individuals, perhaps 100. But this shark, this particular individual, is the last of its lineage. It produced no offspring, found no mate. Its genetic line ends here, in the dark, 3,000 feet below the surface, in water that will remain undisturbed for millennia. The scavengers arrive within hours. Deep-sea fish attracted by the scent of death. Hagfish, sleeper sharks, amphipods the size of dinner plates. They consume the soft tissue, the organs, the muscle. The process takes weeks. Gradually, the megalodon is reduced to its hard parts. Cartilage, teeth, vertebrae. The cartilage will dissolve. Eventually, but slowly. The deep ocean is cold. Bacterial activity is low. Decomposition occurs at a glacial pace. The teeth remain, scattered around the skeleton, each one 5 to 6 inches long, perfectly preserved in the cold, oxygen-poor water. The vertebrae remain, thick discs of calcified cartilage, arranged in a line where the spine once was. Everything else is gone, consumed, dissolved, returned to the ocean. Sediment begins to accumulate. Slowly, microscopic shells of dead plankton drift down from the surface. They settle on the bones, a layer invisible to any eye, but accumulating, day by day, year by year, century by century. The ocean floor rises, imperceptibly, measured in millimeters per 1,000 years. But rising, the bones sink into sediment, buried, protected from currents that might scatter them. Time passes, not human time, geological time. 1,000 years, 10,000, 100,000. The sediment compresses. the weight of new layers pressing down on old. Water is squeezed out. Minerals precipitate. The soft ooze hardens into stone, and the bones within transform. Minerals replace organic material, atom by atom, cell by cell. The teeth, already hard, become harder. The enamel saturated with dissolved minerals. The vertebrae calcify further, become dense, heavy, more stone than bone. This is fossilization, not a copy, not a replacement, a transformation. The same object, the same structure, but different material. Stone shaped by life, preserving the form of something that no longer exists. Millions of years pass. The ocean floor shifts. Tectonic plates collide. The sediment that entombed the Megalodon is pushed upward. Slowly, measured in centimeters per century. But inexorably, the ocean floor becomes a hillside. The hillside becomes a plateau. The sea drains away, retreats to new basins carved by continental drift. What was underwater is now dry land. Desert in some places, forest in others. The fossils remain buried, waiting, hidden in layers of stone that were once ocean sediment. Rain falls, rivers form. They cut through the stone, eroding, carving canyons and valleys, exposing layers that have been buried for millions of years. And in these exposed layers, teeth appear. Massive triangular stones, serrated edges worn smooth by time but still recognizable. The first humans to find these teeth do not know what they are. They are too large to be from any living animal, too perfectly shaped to be natural stones. They are mysterious, powerful. Some cultures believe they are the tongues of dragons, turned to stone by magic or divine intervention. Others believe they are thunderstones, fallen from the sky during storms, gifts from the gods, or warnings. The teeth are collected, kept as talismans, worn as jewelry, ground into powder for medicine. Humans attribute properties to them: protection, healing, power. The teeth become legend before they become science. In the Mediterranean, fishermen find them in their nets, dredged from the sea floor. They call them glossopteri, tongue stones. They do not know they are teeth. They do not know they are millions of years old. They do not know they belonged to the largest predatory shark that ever lived. They only know the stones are strange and valuable and tied somehow to the ocean. Centuries pass. The age of science arrives. In the 1600s, a Danish naturalist named Nicolaus Steno examines glossopteri. He compares them to the teeth of modern sharks. He notices the similarity, the shape, the serrations, the structure. He proposes a radical idea. These stones are not stones. They are fossilized teeth from ancient sharks, larger than any alive today. The scientific community resists. The teeth are too large. No shark could be that size. It is impossible. But Steno is correct. And gradually, evidence accumulates. More teeth are found, in more locations. The pattern becomes undeniable. These are shark teeth. Ancient, enormous, from a species that no longer exists. In the 1800s, the teeth are formally studied. Named. Classified. The species is called Carcharodon megalodon. Later, the name is revised. Otodus megalodon. A separate lineage from the great white. More ancient. More specialized. The teeth are found everywhere. In rock formations on every continent. In ocean sediments dredged from deep water. In desert river beds. In museum collections, assembled from centuries of accidental discoveries. The distribution tells a story. This shark was global. It swam in every ocean. It hunted in tropical and temperate waters. It existed for millions of years. And then it vanished. Scientists attempt to determine why. They examine the fossil record. The last megalodon teeth date to approximately 3.6 million years ago. After that, nothing. No teeth. No vertebrae. No trace. The disappearance coincides with climate change. The Pliocene cooling. The formation of ice caps. The shift in ocean circulation. The conclusion is clear. Megalodon could not adapt to the cooling ocean. It was too specialized, too dependent on warm water and abundant prey. When conditions changed, it went extinct. This is the scientific story. Clean, logical, supported by evidence. But the popular imagination tells a different story. Megalodon becomes a myth again. A monster that might still exist. Hidden in the deep ocean. Undiscovered. Waiting. Books are written. Movies are made. Television shows speculate about living megalodons. The evidence against survival is overwhelming. No modern sighting supported by physical evidence. No bodies. No teeth. No interaction with fishing gear or submarines. The ocean is vast, but it is not unknown. We have mapped it, studied it, sent cameras to the deepest trenches. If Megalodon existed, we would know. But the myth persists. Because humans want giants to exist. We want the ocean to hold mysteries. We want there to be spaces we have not yet conquered. Creatures we have not yet cataloged. Megalodon, in the popular imagination, becomes a symbol of the unknown, of the unknowable, of the ocean's refusal to be fully understood. But the reality is simpler and sadder. Megalodon is not hiding. It is not waiting to be discovered. It is extinct. Completely. Irreversibly. The last individual died millions of years ago. Its body decomposed, became sediment, became stone. All that remains are fragments, teeth scattered across the world, a few vertebrae in museum collections, chemical traces in ancient sediment layers, and the memory, the knowledge that such a creature existed, that the ocean once held predators beyond our current comprehension, that the world was once wilder, stranger, fuller of giants. The teeth sit in museum cases now, behind glass, under lights, labeled with scientific names and estimated dates. Children press their faces to the glass, stare at the serrated edges, try to imagine the animal, the scale, the power. Most cannot. The imagination fails. A 50-foot shark is too large to conceptualize, too far removed from lived experience. So the tooth remains abstract, interesting, but not real in the visceral way that reality demands. The scientists know better. They have measured the teeth, calculated the bite force, modeled the hunting behavior. They understand intellectually what Megalodon was, but even they cannot truly grasp it, cannot feel the weight of 50 tons moving through water, cannot hear the silence of a predator approaching from below, cannot sense the presence of something so large it warps the ocean around it. That experience is lost forever. No human will ever witness a living Megalodon. No camera will ever record its movements. No scientist will ever study its behavior in the wild. It is gone, as thoroughly gone as if it never existed, except for the teeth. And the teeth remain, silent witnesses, proof that giants walked or swam the earth, that evolution can produce forms beyond our imagination, that the past is stranger than any fiction we could write. The teeth endure, long after the museums crumble, long after human civilization ends, long after the next ice age covers the continents. The teeth will remain, stone-shaped by life, waiting in sediment, waiting for the next species intelligent enough to find them. And wonder, what remains when a species dies? Not individuals. Those are temporary, mortal, guaranteed to end. What remains when an entire species vanishes? When every individual has died? When no descendants carry forward even a fragment of genetic code? For Megalodon, what remains is absence, a gap in the fossil record, teeth dated to 3.6 million years ago. Then nothing, the silence where a species used to be. The ocean continues. It does not mourn. It does not remember in the way humans remember. But it changes. The ecosystem reorganizes. The niche Megalodon occupied does not remain empty. Other predators expand. Great white sharks increase their range. Orcas evolve into larger, more sophisticated hunters. The whales freed from Megalodon predation grow larger. The blue whale, the largest animal that has ever existed, emerges in the epochs following Megalodon's extinction. Perhaps coincidence, perhaps consequence, perhaps the absence of Megalodon allowed whales to reach sizes that would have been vulnerable when 50-ton sharks still hunted. The ocean adapts. Life fills every available niche. Energy flows through new pathways. The system balances. But it is different. Megalodon's absence leaves a subtle mark. Not obvious, not measurable in any single variable, but present nonetheless. The ocean without Megalodon is an ocean where the largest predatory shark is 20 feet long, not 60. It is an ocean where no single predator can kill the largest whales, where orcas hunt in packs instead of alone, where the dynamics of predation operate at a different scale. Smaller, more distributed, less concentrated in single, massive individuals. This is the new normal, and it persists through the Pleistocene, through the ice ages, through the extinction of mammoths and saber-toothed cats and dire wolves, through the evolution of modern humans, through the entire arc of human history. We inherit an ocean without Megalodon. We think it is normal. We assume it has always been this way. But it has not. For 20 million years, Megalodon was normal. The ocean we know, the ocean without Megalodon, is the aberration, the diminished state, the reduced version. We have lost the giants. Not just Megalodon. Countless species across deep time. Creatures we will never see. We'll never understand fully. We'll only know through fragments, through teeth and bones, and the faint chemical signatures they left in stone. The fossil record is a graveyard. Every species eventually ends up there. Preserved or lost. Remembered or forgotten. Megalodon is remembered, but only partially. We know its size, its diet, its approximate behavior, but we do not know its sound. Did it make noise while hunting? We do not know its coloration. Fossils do not preserve color. We do not know the details of its social behavior. Whether individuals recognized each other. Whether they returned to the same hunting grounds year after year. Whether they felt anything we might recognize as emotion. These details are lost, irretrievable, swallowed by time. What we have are the teeth, and the teeth tell only part of the story. They tell us about killing, about feeding, about the mechanics of predation, but they do not tell us about living, about the experience of being Megalodon, of swimming through warm Miocene seas, of sensing whales from miles away, of growing from a 6-foot pup to a 60-foot apex predator over the course of decades. That experience is extinct, as thoroughly extinct as the species itself. We can imagine, we can extrapolate, we can build models and simulations and artistic reconstructions, but we cannot know. Not truly. Not in the way we know living things. Megalodon is a ghost, present only in absence, in the negative space it left behind, in the teeth scattered across the world, in the vertebrae compressed into stone, in the chemical traces of ancient predation. This is what extinction means. Not just death. Death is temporary. Individuals die, but species continue. Extinction is permanent. It is the end of a lineage, the closing of a branch on the tree of life, the transformation of living process into geological artifact. Megalodon will never return. Evolution does not run backward. The conditions that created it are gone. The warm, whale-rich Miocene ocean is gone. The ecological niche is filled by other species. The genetic information is lost. There is no resurrection, no second chance, only the memory preserved in stone. And even that is temporary. Erosion will eventually wear away the fossils. The teeth will dissolve. The vertebrae will crumble. Given enough time, even stone returns to sediment. Even fossils are not permanent. They are just slower to fade than flesh. Eventually, there will be no physical trace of Megalodon. No teeth. No bones. No chemical signatures. Only the knowledge. The recorded fact that such a creature existed. Preserved in human databases. In scientific papers. In museums. And those too will fade. Given enough time, human civilization will end. Our records will decay. Our knowledge will be lost. And the memory of Megalodon will vanish. Not from the ocean. The ocean never remembered. From the universe. Completely. As if it never existed. This is the fate of all things. Stars, planets, species, civilizations. Everything ends. Everything fades. Everything returns to the undifferentiated state from which it emerged. But that ending is distant. For now, the teeth remain. They sit in museums and private collections. They weather out of rocks in deserts and river valleys. They are found by children on beaches. Picked up, examined, wondered at. Each discovery is a small resurrection, not of the animal, but of the knowledge that it existed, the awareness that the world once held creatures beyond our current experience, that the ocean was once ruled by giants. That time moves forward, that species rise and fall, that nothing is permanent, not even apex predators that dominated for 20 million years. These lessons are written in the teeth, in the serrated edges that once cut through whale flesh, in the mineral-saturated enamel that survived when everything else dissolved. The teeth are teachers, silent, patient, waiting for anyone willing to listen. They speak of deep time, of processes that unfold over millions of years, of change so slow it is invisible within a single lifetime, of thresholds that once crossed cannot be uncrossed. They speak of specialization and its costs, of adaptation and its limits, of dominance and its fragility. They speak of extinction, not as failure, but as inevitability, as the natural end of every evolutionary lineage, as the price of existence in a changing world. Megalodon was not weak. It was not poorly designed. It was not inferior. It was simply unable to adapt quickly enough, to change fast enough, to survive in an ocean that no longer supported 50-ton predatory sharks. This is not a moral judgment. Evolution does not operate on morality. It operates on function, on survival, on reproduction. And when those fail, when a species cannot maintain its population, extinction follows. Inevitably, mercilessly, without consideration for past success or present magnificence. The ocean holds the memory of every giant that ever fell, compressed into sediment layers, encoded in fossil teeth, written in the chemical composition of ancient stone. But Megalodon was not the only titan to vanish. It was not the only apex predator to fall when the world shifted beneath it. The Miocene and Pliocene epochs were filled with giants, marine reptiles, massive fish, toothed whales larger and stranger than Megalodon. They too are gone, vanished into deep time, leaving only traces, only questions, only the haunting awareness that the world was once wilder than we can imagine. In the next entry, we will explore another giant, another apex predator separated from the surface world for far longer than Megalodon. A creature that ruled not the open ocean, but the crushing depths, the lightless abyssal zones where pressure destroys and cold preserves. A predator that makes Megalodon look modern by comparison. A reminder that the ocean's past contains wonders and terrors we are only beginning to understand. But that is another story, another descent. For now, let Megalodon rest. Let the teeth remain in their cases. Let the sediment continue its slow accumulation. Let time do what time does. Erase, transform, carry forward only the faintest traces of what once was. And in that erasure, in that transformation, find a strange peace. Because Megalodon is not suffering. It is not struggling. It is not fighting a losing battle against a changing world. It is simply gone. Return to the ocean. Return to stone. Return to the deep quiet that waits for all things. The same quiet that waited before the first shark ever evolved. The same quiet that will remain long after the last shark dies. The silence of deep time. Patient. Absolute. Eternal.